All right, lesson 4. Here we come. So I alluded to this lesson being more than the last lesson, and that is true. I don't know that I would say it's a lot harder, um, but it is more because there's more things that can be going on, and let's just break it out. Let's start doing the things. So, what is a rational function? So, there's all this hoopla, right? A rational function is a function in the form this, where a of x and b of x are polynomial functions, and b of x is not equal to 0. Basically, in short, it's like the rational functions we learned about, the reciprocal functions we learned about last time, but we've got variables in the numerator and variables in the denominator. That's really the biggest difference, right? So, just like the reciprocal functions, we can have asymptotes, right? So in the reciprocal functions, we had horizontal and vertical asymptotes. We can have multiple asymptotes this way, and there's also another kind of asymptote we're going to learn about. So let's start walking through a couple of them. First thing is this, we've already pretty much seen. So this is the vertical asymptotes are exactly the same as reciprocal functions, right? Vertical asymptotes are where we set the denominator equal to 0, and it's got vertical asymptote or asymptotes. Sometimes there's more than one in these, right? At at those places, right? So wherever this is true. So that's for vertical asymptotes. What about horizontal asymptotes? So horizontal asymptotes are a little bit more complicated. So there's only ever at most one, right? That's the first thing on here. There's only ever at most one. I just put this for reference. This is the same thing we saw on a previous slide. So if the degree, now the degree, remember, is the highest exponent. So if the highest exponent on the top is greater than the higher exponent in the bottom, there is not any horizontal asymptote. So horizontal being this way, right? If the degree of the top is less than the degree of the bottom, so the highest asymptote on the top, no, too many words, highest exponent, highest exponent on the top is less than the highest exponent on the bottom, then it has a horizontal asymptote at y equals 0. Now, if the degrees are the same, so if the highest exponent on the top is the same as the highest exponent on the bottom, then it has a horizontal asymptote at y equals the top leading coefficient over the bottom leading coefficient. So they can be fractions and all that kind of stuff, right? So let's jump in with an example, and then we'll learn more things. Right, so there's our grid. We're going to graph that thing. So first of all, let's kind of find some puzzle pieces. So the first puzzle piece that we're going to find is we're going to start out by finding the zeros, right? Let's see about doing some colors and see what we can make that works well. So the zeros. So to find the zeros of this function. Now, what are zeros? Zeros are the x-intercepts, right? So we set the numerator equal to 0. So we're going to start by saying x cubed equals 0. Then we'll take the cube root of both sides, and we'll end up with not plus or minus. A, it's 0, and B, it's a cube root, so an odd root, right? So there's just x equals 0. So there is the 0 is at x equals 0. So what does that tell us? Well, that tells us that our graph only crosses at the point, only crosses the x-axis at the point 0, 0. So I'm going to label that as 0, 0, right? Now, I didn't put my graph with the axes on here. You'll see why in a minute. So there's the zeros. Now let's see what kind of asymptotes it has. Well, let's start out with vertical asymptotes. Vertical asymptotes, all we have to do is set the denominator equal to 0. So for vertical asymptotes, x minus 1 equals 0, and then we add 1 to both sides, and we end up with x equals 1. right? So there's a vertical asymptote at x equals 1. So does it have any horizontal asymptotes? Well, in this case, x cubed, the degree of the top is 3, and the degree of the bottom is 1. So since the degree of the top one is greater than the degree of the bottom one, it doesn't have any horizontal asymptotes, right? So that's great. Let's see if we can figure out some points. Let's pick a few. Let's pick a few points. We know it's going to cross. We know it's going to cross the x-axis at 0, 0. Let's pick some other ones. I don't know what we're going to pick. We're going to pick some random things here. So let's see. We may need a bunch, right? We may not. We may need a bunch. We'll see. Okay, so let's do negative. Let's just do our old standbys, right? -2, -1, 0. We already know 0, 0, right? And 1 and 2. Let's see what kind of information we pull out of that, and then make a decision on whether we want to do more than that. So f of, kind of put midline here, f of -2. -2 cubed is -8, right? Because negative times negative is positive. So we have -8 on the top. And then -2 minus 1 is -3. So that, as a decimal, it's going to be 2 2/3. So about 2.7. I'm just going to put 2 2/3. Right? So that. And then how about f of -1? I think I've got plenty of room here. I'm going to kind of make some clarity here. F of -1 equals -1 cubed is -1. All right. So -1 minus 1 is -2. So that's 1/2. So 1/2. So we got some numbers and some things that are getting close here. Let's see what else. Let's see what else we can do. Let's plug in a 1, see what happens. Kind of make me some clarity, right? F of 1 equals, actually, y'all know how to do this. Why don't I pause the video? That way we can save you some time. You can try some of these. You can try these other two, and we'll come back and compare notes in a second. So you figure out these next two and see if you get the same as me. So that's not a ton of information. I'm going to go ahead and just to make our lives easier, I'm going to go ahead and add axes on here. I'm going to shift this one down because at 2, I'm already at 8, right? So if I do it in the middle, then I'm already going to be pushed. Like if I get a lot of extra, I'm going to need some more points, right? 1 was undefined. That was dumb. I just, right. We already knew that, right? Of course, 1 is undefined. All right. But I'm going to kind of go and drop my axis down a little bit here. So the points that we have right now are -2. Let's see. Let's draw in this vertical asymptote at x equals 1. So there's a vertical asymptote right there. Make that a little smaller. Right. So I'm going to label that in there. We know that there is a 0 right here. I'm going to label that with the color that we did it in right there. There's 0 right there. And then I'm going to go ahead and label these -2 and 2 2/3. So about right there, right? -1 and 1/2. Something's going on. It's hard to tell what's going on here. And you might be like, well, it's going to be like, wait, what? It's not quite like the last lesson. Just hold on a second. Undefined here, obviously, 2 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I want to know what it does in here, and I want to know what it does over here, and I want to know what it does in here and over here, right? So I need some more information. So I'm going to plug in a 1/2 for one thing. I know it's a pain in the butt. but you can do it. It's going to be fine. I'm going to plug in the half because I want to know what's happening here, right? And I also want to, or here really is what that's showing. Yeah, that's fine. I want to see what it's doing in this space. Is it going back up here, or is it going down? What's happening, right? That's kind of what I'm wanting to know. And I also want to know whether it's continuing up over here or whether it's got some bend or something. It probably doesn't, but I'm going to do this one over here. So I'm going to do negative 1, 2, 3, negative 3 as well. And then I want to know between here and the asymptote, are we going up or down? What is happening? So I want to do 1.5, 1 and 1/2. And then I want to know what's going on over here. And I'm gonna get a little bit more space to see what's happening. So I'm gonna, instead of just going here, I'm gonna go one more over. So I just want to kind of feel out what's happening in here and get an idea. So 1, 2, 3, 4. So I'm gonna do a 4 as well. So I'm going to do just like I did. I'm going to go ahead and pause, and I'm going to do all of these, and you should pause as well and try it out and see if we get the same thing. So I'll be right back. All right, let's compare notes. Now, you're going to also notice that I added one thing because I wanted to be extra sure of what was going to happen at the asymptote here, right? And so I put 1.1, which confirmed my suspicions, right? So we have these new points, right? I also put 1.1, which is back up here, because what happens in this little section is it actually goes here and then down to here and then turns back up again. And so here is how I knew something was up, right? How did I know it was going to curve back around and something like this was going to happen? Well, because when we found our zeros, we found 1. So there's no way that we can be up here and be heading down and then keep going down. There's no way that was ever going to happen, right? And so we're going down, and then it was still down with this one where we got 6 and 3/4, right, for 1.5, but it had to turn back up at some point because there weren't any zeros over here, right? So that's how I knew something was up, and so that's what went on with that. Now on this side, we figure this other one out, this 13.5. So on this side, it kind of looks a lot like an x cubed function, but with a little bit of a different. So it's like an x cubed function, but with this extra bit here, right? This curves down and never gets that 1. And then it's got this extra bit that kicks it back up. And that's this extra bit down here is what kicks it back up, right? And so, again, I knew that this couldn't cross down here because there weren't any zeros down here. And that's how I knew to go ahead and use this 1.1. I didn't show the work on this one. I actually just pretty much did it in the calculator, right? I just put 1.1 cubed and then divided that by this part I did in my head. And except, did I make a mistake? Oh, no, I didn't make a mistake. 1.1, yeah, 1.1 minus 1 is 0.1, right? So I just got this and divided it by 0.1, which could have probably done in my head. It's just a tenth. Just move the decimal place over, right? That's easy peasy. Okay, so, and I added that extra point because I knew it wasn't going to keep on going down. That was never going to happen. So it had to eventually turn back up. So I just got something really close. And so that's about what happens. It might go down a little bit further than what I drew. We could experiment with that. I don't know what the local minimum here would be. We'd have to do a little bit of other math to figure that out. So let's graph. Well, actually, we're going to get a little bit of notes and graph another thing. So the next thing is oblique or slant asymptotes. So I gave you, I said there was going to be one more type of asymptote, and this is it. So oblique, often called slant asymptote. That's typically what I call it. And this is how to know if it has one. We'll see what it means. So if the degree of the top minus the degree of the bottom equals 1. In other words, and another way to think about this is if the degree of the top is 1 more than the degree of the bottom. So if the top was x, had a degree of 2 and the bottom had a degree of 1, then this would apply, right? Or a 3 and then 2 on the bottom, this would apply. So to find the asymptote, the asymptote, you notice, is a function. It's a linear function, right? It's going to be some line where we divide the top by the bottom. So we're going to have to go back to dividing polynomials and all of that stuff. And in order for this to be true, these have to have no common factors. That's actually a different thing, which will be one final example after this next one, right? So we're going to do this one. So going back to our asymptote rules, does this have any vertical, horizontal, or slant asymptote? So for vertical asymptotes, we should probably put this back on so we know we are. So for vertical asymptotes, I'm going to go ahead and write this up here because that's going to be easy to squeeze in up here, and we're going to have some other work to do. So for vertical asymptotes, it does have 1 wherever this is 0, right? So 2x minus 1 equals 0. Add 1 to both sides. Plus 1, we get 2x equals 1, divide by 2. So it has a vertical asymptote at 1/2. Now, the top has a higher degree. It has a degree of 2, and the bottom has a degree of 1. So the top has a higher degree than the bottom degree, so it doesn't have any horizontal asymptotes. However, as we just learned, it does have a slant asymptote. Excuse me. It has a slant asymptote because 2 is 1 more than 1, right? And so we need to figure out where that is. So we need to go ahead and divide this out to figure out what the thing is, what the equation is of the asymptote. So for the equation of the slant asymptote, right? So we're going to do 2x minus 1 divided into x squared plus 4x plus 3, right? Do simple division. 2x goes into x squared 2x times. We have a slope of 2, looks like, right? And then we distribute this back out, and we go in... we can't, hold on, time out. It doesn't go into it 2x times. That's not right at all. It goes into it a half x times, right? Right? And just, if you have the same brain, little brain fart or whatever you want to call it, like I just had, we're doing 2x goes into x squared. So x squared divided by 2x. So 1/2 x, right? That's not 2x. It goes into it 1/2 x times, so a slope of 1/2, right? And half times 2x is x squared, because the half and 2 cancel, turn into 1, x times x squared, right? Half x times times -1 is minus a half x. 1/2 x. And then we're going to subtract that, right? So change both the signs. This one cancels. 4x minus a half is 3.5. 3 and 1/2 x. It's probably easier to do, 2x goes into 3.5 x. I'm going to bring down the plus 3. 2 goes into 3.5 x. The x's are going to cancel, right? But 3/2 divided by 2, it's going to be easier to convert this into a mixed number. 2 times 3 is 6, plus 1 is 7. So that's 7/2 divided by 2, which is the same as a half, right? So hold on. I knew something wasn't right. Y'all probably already caught it. 4 changed to a 3 for some random reason. So 4.5, which would be 9/2, right? 9/2. So 4.5 divided by 9 by 2. So 9/4, right? So plus 9/4 fourths. Ugliness. We're actually pretty much done. But 9 fourths times 2 is 4.5 x. Right? So multiply the 2 and it cancels that one. Go back to this one. Right? 9 fourths times -1 is -9 fourths. So then we're going to subtract it. That one cancels. 3 plus 9 fourths, so 3 plus 2 and let's see, what is 9 fourths as a thing? That'd be 2.5. Is that right? 4 and that is 8. No, 2 1/4 plus 3 is 5 1/4. We don't care because we don't care about the remainder. So the slant asymptote is this without the remainder bit, right? So it's that. So the slant asymptote is at, let's call it A for asymptote. A of x equals 1/2 x plus, we'll write 9 fourths as a mixed number. It's going to be a lot easier to think through, right? All right, so that would be 2 1/4. Right? So let's get our axes on here and let's get this slant asymptote drawn on there as best we can with it being a little bit ugly, right? So let's go ahead and draw the axes right here. That looks fine. And then right here, that looks fine. We should also find the zeros real quick. So the zeros would be this. So the zeros, that there, the zeros would be when we're gonna solve this one when that one equals 0. So x squared plus 4x plus 3 equals 0. 2 sets of parentheses. A equals 0. X 3 and 1. 3 plus 1 is 4. Positive times positive, it works. So when we separate this out, it's going to be x equals -3 and -1, right? So we have zeros at -1 and -3, right? So there's our zeros. Excuse me. The y-intercept is where? So the y, I don't know if we did this on the last one, but it's a good idea to have that y-intercept on there. So where's the y-intercept? Let's find that. So the y-intercept would be whenever x is 0, right? So if we set zeros in here, it's going to kind of cancel all of this mess. So 3 over -1 is -3. I'm going to kill off those scratches. So the y-intercept is at 0, -3. That's another point we can use. So 0, -1, 2, 3. The vertical asymptote is right there. We can go ahead and dot that in there. And we'll also dot in this slant asymptote as well. So the vertical asymptote is at x equals 1/2. So right in here. All right, so let's make that dash. There's a vertical asymptote where it doesn't ever touch there. And then we've got a slant asymptote right there. And I left that white. So it's got a y-intercept at 2 1/4. So I don't think I want to do it white. I think I'm going to do it this pale green color. All right, so at 2 1/4, so 1, 2 1/4, and then up 1 over 1, 2, so right here, there, so here, right, it's going to be hard for me to do it just perfectly, but it's going to be like that, and then down there, down here. If I had a ruler that was longer, it would be easier. So right there, as best as we can draw, make that dash because that's also slant. That's also an asymptote, not a part of the graph. Okay, so we've kind of got our quadrants. We know part of it's going to be like this. This is probably enough to be be going on with, right? Probably. We may want to see what it does. It probably just curves here and probably hits over there. So it's probably going to, why is this not drawing? Let me pause and figure out what's wrong with my tools. Oh, I just figured it out. Never mind. Cancel. No, I don't want to rename anything. Great, there it is. It's probably going to look something like this, where we get closer and closer to the thing, but never getting there. And then around, something like that. We may want to get another couple of points just to be sure, right? This one's never going to get to the x-axis. So which part of is it up here? Where is it going to be like this? Or is it going to be, it's not going to be like this. So it's almost certainly going to be up there somewhere. So we need some points in here and maybe some points in here. So let me erase some of my scribbles, because I'm just kind of, based on the points that we can see, that's probably kind of what it's going to look like, right? Just guessing. So let's pick some points to plot in there for our little t-chart. So let's pick a point here. So what is that? -2. So -2. And let's pick a point over here that we can see what it's doing. Let's pick one far enough away to see whether it's curling back down here or whether it's going to try to hug this asymptote, because that's really what we need to know. So let's pick like this one over here. Is that -7? -1, 2, 3, 4, 5, 6, 7. So -7. So again, we just, all we really want to know is, does it like curl around here, or is it going to come and try to get closer to this asymptote? That's really what we need to know there. This is probably that we don't really need to know anything else here. That's pretty much a sure thing, right? It's going to be cutting down that way, right? Because it doesn't curl back up. There's no more zeros up here. So this part of the graph is pretty safe bet. That's what that part's going to look like. Now, what about over here? So we need maybe 3 points in this region. So let's pick, how about a +2 and a +4, and then maybe a +7, right? 1, 2, 3, 4, 5, 6, 7. Yeah, 7. So maybe those. So I'm going to go ahead and calculate those. You do the same. I'll boop it in and we'll compare notes. All right. Did you get the same numbers as me? Got all the work? I also added one in there. It seemed pretty obvious what was happening in here, but I wanted to know kind of how steep this section was, and so I went ahead and did one as well, how quickly it looked like it was headed that way. So we've got this one, this part kind of goes here and goes back up to 5, so it kind of cuts down, and then it's over here and heads this way. Something, let's see. I probably have not drawn this quite right. It probably doesn't come in. Let's see. Let me get this part drawn in here. I'm doing the best to draw it. What is this supposed to be? 6.15. So like barely over 6. So like right in there. And then this, so it scoops just barely. I think I did that too steep. This is be straight. Something like that with the resolution we're able to draw. And then this one does in fact do what it kind of looked like it probably did. Went and hugged this asymptote there, and then we've got a little shallow bit right there, and then we already determined that this was obviously what this part looked like. So there it is. Okay, one more thing, and that is a point discontinuity or a hole, right? So normal rational function b of x, it does not equal 0. And x minus c is a factor of both of them. So if they have a common factor, then there is a hole at x equals c. So let's do one more problem, and then we're going to be finished, right? So we want to graph this guy. Let me bring back up this thing. So let's find all of our things. Does it have a vertical asymptote? Yes, it does. So a vertical asymptote at, I think putting it up here is still a great idea. Vertical asymptote at x minus 4 equals 0, so x equals 4. So let's put our axes on here. I think we can go with, we'll find out in a second. Hopefully I don't have to erase all this. Erase all this work. I think we can put our kind of normal axes on here. I think. We'll find out in a second. So it's got a vertical asymptote at x equals 4. 1, 2, 3, 4. So right here, there's a vertical asymptote. Bam, bam, bam. Slam, bam. Thank you, ma'am. Blap, blap, blap. Right? There it is. Great. What about our zeros? So our zeros at x squared minus 16 equals 0. I'm going to go ahead and solve this with the square root method. So I'm going to add 16 both sides, end up with x squared equals 16. And then when I take the square root of both sides, now this is the part we got to remember, which is one of the reasons why I'm doing this. This is 16, not a 6. Is that when we take the square root of both sides, you get plus or minus, right? So we have zeros at x equals plus or minus 4, right? So that's interesting. Now, wait a minute. That's interesting. When we factor this out, let's wait. Oh, you should have probably figured this out, right? When we factor this top one, it factors into x plus 4 and x minus 4. It actually has a hole at x minus 4. So what does that mean as far as our asymptote goes? So what does it mean? Well, here's what it means. It means that this isn't here. It's actually a hole right there. So what does our graph look like? Well, our graph is going to look like this. So if we turn this into this over x minus 4, then what's going to happen is these are going to cancel, but we got to know that there's a hole right there, and it turns it into a graph, the same graph as f of x equals x plus 4, so whatever is left, right, with a hole. So how do we draw that? Well, we do it like this. We draw this. This turns out to be a line. It's not always a line. It could be a parabola or whatever else. It turns out to be a line in this particular example. 1, 2, 3, 4 here, and then up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. But there at 1, 2, 3, 4, at positive 4, there is a hole there, right? So there's a hole at the opposite sign of whatever one we canceled, right? So it's because it's the x minus c. It's if we go back and look at the instructions, right? It's got a hole at x equals c, and the x minus c is the factor. So we've got to flip that sign, right, in order to figure out where the hole is. So let me put this back in. So here, instead of putting a dot, we're going to put a hole. And so this graph looks like this. Looks like a line with a hole right there. And that's what that one looks like. And that is it for this lesson. Hope it's been a good one. Hope it hasn't been too confusing. It's not, I stand by what I said at the beginning, that it's not exactly super hard. It's just kind of a lot. There's a lot of pieces. You can do it. Take your time. Learn all the steps and the rules. You got this. We'll see you in the next one. Bye-bye.